Okay guys, I've had a lot of people ask about 3D printing, how it works, what the technology is, all kinds of questions, so I figured I'd do a really quick video about the very simple basics of 3D printing. I'm not going to get into great detail. This video will probably be one of a series. I'll call this one part 1. So 3D printing has come a long way from where it used to be a long time ago, and when I say a long time ago, it may be 5 years ago. Technology changes so quickly that you could actually refer to 5 years ago as being ancient history, especially in regards to the 3D printing and the technology. So the simplest way it was described and explained to me was, imagine you had a hot glue gun and you could squeeze out a bead of the glue and wait for it to dry, cool down, and then you could continue to put another bead or layer on top of that, and you would just continue to build it up until you had a structure. So 3D printing works the same way, at least with my machine. It's a fused deposition model 3D printer, which means it builds in layers and it builds from the bottom up. So just using the simple paint program here, everything is built onto a build plate or platform, if you will. So you would just drop down a layer of filament. Now filament is it can be different forms. Mainly for me right now anyway, it revolves around PLA, which is a form of plastic. It is environmentally friendly. It will biodegrade under certain circumstances, and it's extremely easy to work with. Seems to do really well. So keep in mind with 3D printing, we're using the plastics and we are melting the plastics. Now also remember, we are not burning plastics, so there's no real fumes or smoke or anything like that. We're just heating it up into a liquid form, and we're also trying to cool it down so that it will harden again. So if we have our one layer that we lay down, we're going to come with the next layer right across. And once again, excuse my drawing skills. And we're just going to keep building these layers up. And as we build the layers, we start to form a solid object. The idea is to melt the PLA, or the plastic if you will, into a liquid form. And as it's building these layers, it's cooling down before the next liquid layer gets on top of it. So with my poor skills here at drawing, you can see that I have essentially a wall. So if we can just build a solid block of plastic, that's one thing. Now the real trick is when we start to do complex shapes. Now keep in mind, we're not just simply printing a flat two-dimensional object. We are actually using 3D. So let's say that we needed to print a circle, or better yet, maybe an arch. So as I described, we would be starting at the bottom with a flat layer. And let's just say our design had an arch in it, like this. So now, taking a little bit closer look at the arch itself, you may ask yourself, how is it possible, if we're printing in layers over here, that we can make this shape? So if we were to use your imagination a little bit, and we take a look at our arch and how it would form. Now let's take the bottom half of a circle, for example. Let's just call that the bottom half. As we build layer by layer, let's make this a little smaller. As we're building layer upon layer, and like I said, you're going to have to use your imagination, because this is going to be a very poorly formed circle. These little layers, you see, they extend out. The layer that goes on top, the next layer, extends just a little bit further. And eventually, if you were to extrapolate this all the way out, you would see that slowly it is starting to form an arch or the circle. So that's just real basic on a shape. So if we were to actually continue this over to here, or had this side here trying to finish, eventually it would go ahead and fill this circle in. So now we have not only just a basic wall shape, but now we can also do circles. And also remember with 3D printing that we have 3 planes. So you have a series of axes, which is there's 3 total. So you have essentially, say, a forward or a far and a near axis, and we can call that X, for example. So also from left to right you have the Y axis. So this is 2-dimensional. So with everything that you do, you can move an object left or right and forward and backwards. So that's 2D. Well, with 3D, there is another axis, another plane, if you will. And this is not going to be a good demonstration, but imagine there is another axis here. And this one is not forward or backwards, it's not left or right, but it's also up and down. And that's what gives you the 3D. Now this one is called Z. So taking that information, we can plot different points wherever we need it to be, whatever the axis location is. And of course we can break this up into grids and find out exactly where that point is. Now, keeping in mind the red is just simple 2D, but then we're going to actually add in the Z axis as it's referred to, and that's going to create our item in 3D. And if we need to find a point somewhere along the 3-dimensional plane, then we have 3 different, I'll call them directions essentially, that we can choose from to locate exactly where we need to be. Okay, so that is a very poor way to explain that, forgive me. So anyway, I'm going to go ahead and stop this video and start with a part 2. Now, keeping in mind, I will draw very poorly and very quickly a rough sketch of what my 3D printer looks like. So essentially you have 2, I'll call them support beams, and you have a gantry across the top. And let's just imagine this is my machine itself, and also you have a build plate, and this build plate here is able to move we'll call it backwards and forward. The gantry here is able to move up and down. Poor skills, I told you. It's able to move up and down. So if this is going forward and backwards, this is going up and down. We've already met 2 of our 3D dimensions, and now we're actually going to add in what's referred to as the nozzle or the hot end. So the hot end is essentially a enclosure that has a heating element inside of it. This heating element heats up. For example, I print on average somewhere around about 200 degrees Celsius, which is roughly 400 and some degrees Fahrenheit. At the very bottom of the heating element, we have the nozzle. And then, of course, over here on the side, you'll have a spool of filament. And there's also a box up here which is motorized, and it's what they call the extruder. So your filament would actually come off of your spool. It would go through the extruder, which basically pushes the filament into the hot end and out through the nozzle to start building our layers back and forth here and creating whatever our item is. So we talked about the 2D. So the platform here is able to move forward and backwards. The gantry here, whole arm, both sides, this whole thing, is able to move up and down. Well, when we come to this, the hot end with the nozzle, it's actually able to move left and right. So now the position of where this filament is going to come out at, with the up and down movement, forward and backwards, left and right, we now have the whole three-dimensional plane. So essentially it becomes kind of like a plotter. But anyway, I continued too long. I'm going to go ahead and stop this one and tune in for part 2 if you find this kind of interesting.